Hey fifth graders, it's time for Unit 4 Lesson 10, and we're going to start looking at division today. So we've been looking at multiplication for a long time, and multiplication and division actually go hand in hand. So we'll use some of the things that we learned from multiplication to help us with this today. The very first thing I would like to do is just review the overall division strategies that you learned way back in the day. So it's been since 3rd grade, it's been a while, but basically with basic facts. 32 divided by 8. I would call that a basic fact because that's one of them that you are accountable for in 3rd grade, like 0 through 10s. Okay, so if we have 32 divided by 8, when you first learn how to divide, one thing that you learned was equal groups. So that's one strategy for division. So if we're saying 32 divided by 8, this means that you have 32 items. And I want to know how many groups of 8 can I make out of that 32. So one of the strategies that you used, I don't know if you remember doing it, I'm sure as you start drawing all these little dots you will, was that you drew 32 objects, and I'm just going to make circles. So draw 32 circles. All right, now they don't have to be in the same as mine. You can draw them however, you can draw them all over the place as long as you have 32 circles. So 32 divided by 8 means you have 32 things, and I want to know how many groups of 8 there are in 32. So that means I'm going to circle groups of 8. So I see 1, 2, 3, 4, 5, 6, 7, 8 right here. There's one group of 8. I can make more. There's 6, and I need 2 more. 7, 8, 2, 4, 6, 8. Okay, and then I see 1, 2, 3, 4, 5, 6, 7. There's another 8, and 1, 2, 3, 4, 5, 6, 7, 8. 8 here. So where's our answer? Well, I see 1, 2, 3, 4 groups of 8 within the 32. So 4 would be our answer. That was one strategy that we learned. We also learned that we could skip count by the number we're dividing by. So in 32 divided by 8, I want to know how many times does it take, if I count by 8, to get up to 32. And that's kind of similar to this, right? 8, 8, 8, 8, except we're going to count up to get to 32. So if I count by 8s, 8, and an 8 plus another 8 would be 16, plus another 8 would be 24, plus another 8 would be 32. And once you get there, we see how many times did it take? Well, there's 1, 2, 3, 4. I had to count by 8 4 times to reach 32. That means 32 divided by 8 is 4. All right, another strategy you learned was repeated subtraction. We know that multiplication is repeated addition, right? Well, division's the opposite of that. Sorry, division's the opposite of that. It's repeated subtraction. So I'm going to start with this 32 and see how many times do I take 8 away until there's nothing left. So 32 minus 8, that would give me 24. And 24 minus 8, that would give me 16. 16 minus 8 gives me 8. And 8 minus 8 gives me 0. So once I get 0 down here, I see how many times did I subtract 8? Well, there's 1, 2, 3, 4. I had to subtract 8 4 times, so that 4 is my answer. And the last strategy that you learned, I could have been the first, all 4 of these were kind of learned around the same time. The related facts. So you remember we have these math mountains, right? And we have them for addition and subtraction. We also have our multiplication and division. So with this, I'm going to put the total up at the top. That's always the number I'm starting with in a division problem. And an 8 here, and I have a box here. So 32 divided by 8, 32 divided by box, 8 times what? So hopefully this is coming back to you. So if I want to know what 32 divided by 8 is, I can ask myself 8 times what is 32? And if you were asking yourself 8 times what is 32, you might count by 8s and see how many it takes to get to 32. That repeated addition for multiplication. So 8, 16, 24, 32. 8 times 4 is 32. So no matter how you'd solve this, 32 divided by 8, we see, is 4. And these strategies were excellent when you were in 3rd grade, right? Because all of the facts that you had were kind of lower numbers, right? So in 5th grade, you're going to be dealing with problems like 136 divided by 8, okay? And if you have to solve 136 divided by 8, I don't know that you're going to want to have to draw 136 circles and circle 8 of them, or that you're going to want to count by 8s up to 136, or that you're going to want to start with 136 and subtract 8 a whole bunch of times. And I don't know that we would know 8 times what is 136. So while these strategies are great for lower numbers, we need to add on to that to deal with our higher numbers that are expected for 5th grade. The good news is you'll kind of be able to visualize these and use these strategies. We'll just have to beef them up a little bit. We'll add a little bit of your prior background knowledge to help you out. And the first way, there's 2 ways I'm going to show you. Neither of those ways, parents and guardians who are watching this, I'm sorry, the standard algorithm for division is not until 6th grade. So we're going to use visual models to help your child develop number sense around this. And then next year, they'll learn that standard algorithm. So I'm sorry, I won't be teaching that because I'm not supposed to. So if you can withhold until next year, let your child develop their number sense around it and using these multiples of 10 to help them. All right, anyhow, I'm off my soapbox. We can use the area model for division too. I know we used it for multiplication, and I have just a couple problems here for us to review that. And then that's going to help us when we're trying to figure out, okay, well, how do I use this for division? So first of all, the area model uses rectangles, right? And we know that the area of a rectangle, what's inside is length times width, or in this case, like 7 times 56. Our goal is to figure out how much is on the inside, right? And we saw that with 7 times 56, because those were larger numbers, that we could break it apart by place value to make it a little easier for us. So because this is a rectangle, I took the 7 and we put it on the shorter side because 7 is lower than 56. And we broke up 56 by place value into 10s and 1s. And these were things that we could do in our head, right? If you know that 7 times 5 is 35, then we know that 7 times 50 is 350. And 7 times 6 is 42. Now, if our goal is to find the area of this whole thing, we just added those together. We took 350 plus the 42. Now, maybe you didn't need to write this out. Maybe you just knew, okay, well, there's 2 1s, 9 10s, and a 3. Yeah, 392. That's fine. That is our answer, right? The area of this thing is 392. And that's why it's called the area model, length times width. Now, this one we didn't really work too hard on. I think I showed you one example maybe in class. But you can use this strategy for numbers that are greater than 2 digits. We're still going to break it up by place value. So I'm going to put the 4 here. And now I'm going to have 3 sections because I have 3 digits. So I could break this up into 200 plus that 3 represents 30 plus the 4 1s. And again, we can use our multiplying by multiples of 10 strategies to help us just do these in our head. If 4 times 2 is 8, then 4 times 200 is 800. If 4 times 3 is 12, then 4 times 30 is 120. And 4 times 4 is 16. And of course, to get the area of the whole thing, we just add up all 3 of these. So 0 plus 0 plus 6 is 6, 2 plus 1 is 3, 8 plus 1 is 9. That means the area of this whole thing is 936. Okay, so now we're going to apply this to division. All right, so flip over your page. It says you can use this model to help you understand and solve divisions as well. So we have 320 divided by 5, right? And with area, aren't you trying to figure out what times what? Or, sorry, you multiply the length and the width to get the total, right? Well, with division, you're given the total first. So if you want to say 320 divided by 5, that means I know that inside here is equal to 320. And I'm just going to write it up in the corner. You'll see why in just a moment. But the area inside here is 320. So in a division problem, that would be the area. And this 5 right here, that's one of my sides. So I'm going to write it along the shorter side here. And basically what I want to know is 5 times what is 320? Okay, so this is the area model still, except in this case, you're given the area and you're missing one of the sides. That's what happens with division. So how can we figure out 5 times what is 320? Because I don't really want to count by 5s, okay? And basically, we can use our area model for multiplication to help us, and our multiplying by multiples of 10 strategies to help us. Okay, so I'm going to break this up. In our other examples here, you don't have to flip it over, but we broke up this 392 into 50 plus 6, right? We broke up 56 into 50 plus 6, and this 392 was broken up into 2 pieces. So we're going to kind of work backwards here. We can draw a line right down here, and I basically am going to figure out like what plus what up here. And then if you can figure out what plus what would give us 320, then we'll know our answer. So bear with me. It's only the first one. We've got plenty more after this. So I'm going to ask myself, and we're just doing it one piece at a time, 5 times what would get me closest to 320? Well, if you recall from this, when I was trying to do 7 times 50, I started off with 7 times 5 is 35, and then I knew I had to add the 0, right? So I started off with those first 2 digits. You can do that here. Start off with the first 2 digits, because 5 times nothing is going to get me 3, right? 5 times what would get you closest to 32? 5 times 6 is 30, right? So 5 times 6 is 30. 5 times 60 is 300. So 5 times 60 is going to get us closest to 320. I couldn't do 5 times 70 because that would give me 350, which is more than 320. So now I want to see, okay, how much is left, okay? And to figure out how much is left, we subtract. 0 minus 0, 2 minus 0, 3 minus 3 I don't need to write. Okay, so right now I know that 5 goes into 320 at least 60 times, but there's still some left over, right? So that means I still have more of this rectangle to work with. So I'm going to take this 20 and now ask myself the same question. 5 times what gets me closest to that 20 that I still need to figure out? Well, 5 times 4 is exactly 20, right? And now there's nothing left over. That means the answer to my problem of 5 times what gives me 320 is 60 plus 4. Which is 64. So 320 divided by 5 is 64. Now you might be thinking, well, this takes way longer than, you know, the standard algorithm. Maybe you've seen it already. Honestly, if you start doing these things in your head, it's taking longer because I'm walking through it all with you. When you start doing these on your own, it's not going to take that long, okay? Now, if you want to check to make sure that you're right, shouldn't 5 times 64 give you 320? Yeah, so let's double check it. 64 times 5. 4 times 5 is 20. 6 times 5 is 30, plus 2 is 32. Yay. I know that we're right. So our answer is 64. All right, let's do some more. Try it. I have 136 divided by 8. So I want to ask myself, 8 times what is 136? All right, so let's start off with this 136 here. 8 times what's going to get me closest to 136? Remember, I've got 3 digits here. I'm just going to look at the first 2. So 8 times 1 is 8. 8 times 2 is 16. That would mean 8 times 20 is 160. That's too big, right? So really, I'm going to be working with 8 times 1 is 8, and I'm going to put that 0 to have 80. So 8 times 10 gets me closest to 136 without going over. Okay, now to figure out how much is left, I'm going to subtract. 6 minus 0 is 6, and then 13 minus 8, or maybe if you want to borrow, same thing. 13 minus 8, that will give you 5. So I still have 56 left over. I'm going to bring that over here and ask myself, 8 times what gets me closest to 56? 8 times 7 is exactly 56. None left over. What's my answer? My answer would be this 10 plus 7, which is 17. And if you don't believe me, then shouldn't 17 times 8 give you the 136? It should. So let's double check. 7 times 8 is 56, and 8 plus 5 is 13, and check. I know that 17 is right. All right, look at the next one. I need to know 6 times what is 252. So let's start here. 6 times what is going to get you closest to 252? Well, I can't do 6 times anything to get to 2, right? So now I'm going to look at this 25 and use my multiples of 10. I know that 6 times 4 is 24, right? That means 6 times 40 would be 240. So 40 is going to be our first number here. So 6 times 4 is 24. 6 times 40 would be 240. And we subtract. 2 minus 0 is 2. 5 minus 4 is 1. And there's nothing left here, right? So I have 12 left over. 6 times what gets you closest to 12? 6 times 2 is exactly 12. None left over. My answer would be 40 plus 2, which is 42. So that's the answer to our problem, 42. 6 times 42 gives us 250. So we're really just using the related multiplication fact here, asking ourselves, 6 times what is 252? 6 times 42 is 252. And again, you can check with multiplication. 42 times 6. 6 times 2 is 12. 6 times 4 is 24 plus 1 is 25. 252, 252. I know that I am right. Okay. Next one, 468 divided by 9. So I want to know 9 times what equals 468. Okay, so I have to ask myself, 9 times what will get me closest to 468? So let's look at this 46 here. 9, 18, 27, 36, 45. Okay, so 9 times 5 is 45. 9 times 6 is 54. That's going to be too big. So 9 times 5 is 45. That means 9 times 50 is 450. That gets us closest, because if I try to do 60, that's going to be too big. We subtract. I'm left with 18. Now 9 times what is 18? 9 times 2 is 18. There's none left over. 50 plus 2 is 52. To double check it, I can do 52 times 9, and you'll get 468. I promise. You will. But if you were taking an assessment, I would definitely want you to multiply that out and double check your work. Okay, now I'm kind of up in the game here. Instead of 3 digits here, I have 4 digits divided by this 7. So I want to know 7 times what is 3,822. Okay, it's a little bit bigger, but I can still use the same strategy. I'm just going to look at these first 2 digits here, right? And then the rest of these can be replaced with zeros. So 7 times what would get me closest to 38? Well, 7 times 5 is 35, right? 7 times 6 is 42, so that's going to be too many. So 7 times 5 is 35. Then I would need 7 times 500 to get me 3,500. So you're using that, multiplying by multiples of 10. We're going to subtract. 2 minus 0 is 2. 2 minus 0 is 2. 8 minus 5 is 3. So now I got a little bit larger of a number here. That's okay. We're going to move it over. 322. So 7 times what gets you closest to 322? This is just like those other ones up here. So I'm going to look at my first 2 digits here. 7 times what gets you closest to 32? 7, 14, 21, 28, 35. 7 times 4 will get me closest without going over. So if 7 times 4 is 28, that means 7 times 40 is 280. I'm going to subtract. 2 minus 0 is 2. 12 minus 8 is 4. I need another column because there's still some left over. So I'm going to take this 42. And 7 times what gets me closest to 42? Well, 7 times 6 gives me exactly 42. And now I have none left over. So what's the answer to this? My answer is 500 plus 40 plus 6. So 5 hundreds, 4 tens, and 6 ones. 546. All right, there's 2 left. If you are feeling like you could pause me and try it on your own, go for it. If you're not quite there yet, don't worry about it. All right, so I want to know 9 times what gets me 2,106. So I'm in the thousands here. I'm probably going to need 3 boxes, just so you know. You can be prepared. All right, I'm going to look at the first 2 digits here. 9 times what gets me closest to 21? 9, 18, 27. I can't fit 3. So 9 times 2 is 18. That means 9 times 200 would give me 1,800. All right, we subtract. 6 minus 0, 0 minus 0. I'm going to go ahead and cross that off. I know you're used to it. 8, 9, 10, 11. So we're left with 306 here. I'm going to take that 306 and carry it over and use the same process. 9 times what is going to get me closest to 30? Well, 9 times 3 is 27, right? That means 9 times 30 would give me 270. And we subtract. 6 minus 0, can borrow from that 3. 10 minus 7 is 3. So there's still some left over. I'm going to carry it over to this next box. 9 times what gets me closest to 36? Well, 9 times 4 is exactly 36. So I have none left over. That's how I know I'm done. My answer is going to be 200 plus 30 plus 4. 2 hundreds, 3 tens, 4 ones. If you wanted to line that up like this, you're more than welcome to. If you can just pop that into your head also, that's fine. Whatever works best for you. All right, here's our last one. I want to know 4 times what gives me 3,372. All right, so I'm going to look at my first 2 digits. 4 times what gets me closest to 33? Well, 4 times 8 is 32. That means 4 times 800 will give me 3,200. Okay, that's the closest I can get with my hundreds. So I'm going to subtract 2 minus 0, 7 minus 0, 3 minus 2, 3 minus 3. So I have 172. I'm going to need to carry that over because we're not done yet. So 4 times what would get us closest to 172? I'm going to look at my first 2 digits. I know that 4 times 4 is 16. That's as close as I can get to 17, right? So if 4 times 4 is 16, that means 4 times 40 is 160. 2 minus 0 is 2. 7 minus 6 is 1. I'm going to take that leftover and carry it to my next box. And 4 times what is 12? 4 times 3 is exactly 12. There are none left over. So now I know I can say, okay, 800 plus 40 plus 3 is 843. And again, if you want to check to make sure that you're right, just take 843 times 4, and you should get your 3,372. 4 times 3 is 12. 4 times 4 is 16 plus 1 is 17. 4 times 8 is 32 plus 1 is 33. And I see, oop, those match. Boom. That means we're right. So you can check every single one of your division problems. That's it for today. Thank you so much for watching.